see what we last time on Monday. I think that we're in a good shape in terms of covering this material. We looked at the special formula that could be used if you cannot take the integral using the other approaches. You only have to use this formula if you can do the integration using substitution or some other method. But since there are various ways of doing the exercises, then it's definitely helpful to see them. But sometimes this will be the only method that you can take. For example, the integration of ln, which can only be done using so-called integration by parts. So ln we cannot integrate, but we can find its derivative, which is 1 over x. So I call ln as a u, and whatever is left, and that's just dx as a dv. So when I integrate dv, I get v, and that's actually x. Antiderivative of 1 is x. And then they set it up in such a way that they have u times v, the product, and that's going to be multiplying ln by my v, which is v, x. So x times ln x. And then subtract, according to formula, it's integral of v times du. So whatever they are, v, and that's our x once again, du, which is whatever came out here, derivative 1 over x. And notice the whole point of this use of formula is that your integral now is going to be of only dx, no ln in it. So you can definitely take that integral. So the biggest problem is always finding antiderivative taking the integral. Now, since it's a definite integral, then you're going to plug in upper and lower limits. So first you go with upper, which is e. So you go here, e times ln e. Notice that ln e is 1. I think they worked out this exercise in a very detailed way, so that's great. And then x, again, you plug in the upper limit, which is e, so you're going to get just instead of x, you put e, where you put e? Oh, here it is. They put e here. And then some more stuff at 1. So the point of story, you can, I guess, easier take care of this yourself rather than reading the solution. And that's why I always recommend you to do homework, do problems that are already done, so you can always compare with ready solutions, with ready answers, in the case you get stuck. So we looked at an exercise last time, and I know that this weekend is actually a long weekend. Did you know that? It's a Veterans Day holiday, no classes on Friday, but when you say, Alex, we don't have class on Friday anyways, and that's absolutely correct. So since you don't have a class on Friday, but you miss the holiday this week and the following week, I guess today I'll try to be shorter and just let you go to start celebrating if you do, or catch up with your homework if you don't. But the thing is that it's a national holiday. All colleges and universities are closed, and that's analogous to the Thanksgiving, right? On Thanksgiving, by the way, we're not going to have a chance to celebrate either, but we'll think of something, right? But this end of semester, there are quite a few holidays coming. So I'd like to do another exercise using this integration by parts method. And I just saw problem number 10 that I think is good to do to refresh what we were looking at before. In this exercise, when we have x multiplied by the square root from 1 minus x, what I want to do is a little substitution here. So what I want to do is recall that whenever you had some kind of parentheses, and whenever you square root this, you can replace it with a new variable letter u, 1 minus x, then you might get just the substitution going instead of going with this parts approach. I think that substitution is always something that is interesting and worth trying, because integration by parts is pretty tedious. So if I take derivative of this, it's going to be -1. So multiply by dx, right? Because minus x has derivative of -1. And that's going to be du. So I'll be able to replace this with a negative du, right? Because dx will actually be the same as a minus du. Change signs on both sides. And the other piece here is x. Notice that out of this substitution, I can say it's 1 minus u is equal to x. So the point is that we can integrate now, because we're going to have, instead of our x, 1 minus u. Then we have a square root from u, and then multiplied by negative du. So that minus from du will go on the outside. I will write this as a power, right, square root as u to the power of 1/2, and distribute like that. Okay. So we're gonna end up with 2 pieces to integrate. One will be u to the power of 1/2, and the other will be u to the power of 1, and 1/2 is 3/2. And du is here with us. So there is no need in parts. It's just our favorite formula. I hope you still remember it. The power will give you n plus 1 for the power divided by n plus 1, and of course the constant. So we're gonna think about adding 1. So 1/2 plus 1, which is gonna be plus 2/2. See the same arithmetic throughout all of these sections with antiderivatives. So you get a 3/2, and then I divide this also by 3/2, right? I selected this exercise to refresh your memories on use of substitution. So now what if I add now to the 3/2 number 1? Again, I'm gonna add 2/2 instead of adding 1, and that'd be 5 divided by 2. So it's 5/2, and that same 5/2 I put in denominator, right? So that's a routine procedure now for us. Now notice this should be in the parentheses because the minus is in front, and we'll also put plus the constant, right? And now I need to go back to my original variable x. So I think I'll write it here, it's not much room. So it'll be negative. Now this denominator 3/2 has to be reciprocated, right? So it'll be 2/3. And the letter u will be raised to the power of 3/2, but instead of u, I get 1 minus x. So I'll just put power of 3/2 instead of square root and then cube. I guess it's not going to make any difference. Now there is another minus and minus, so it'd be plus. Now we get 2/5. And again, in the parentheses is 1 minus x, power of 5/2, plus the constant. So if you can't do substitution, then you use parts. If you can do substitution. Advice is do the substitution, and that's what I would say is happening here in the problems, starting at 12 and going through 18 for sure. Well, exercise number 17, I don't think you'll be able to substitute, so I think it's worth doing using parts, because there are two functions here involved, e to the power and x, and that's what will stop me from doing substitution. Alex, how did you know it? Well, I tried, it didn't work. It's people say from experience, but you can always tackle it if you feel like over the weekend. So here's our integral that will go from 0 to 1. And now I need to decide what should I integrate and what should I differentiate. And we usually differentiate x because it disappears. Because if I take derivative and call it as a u, then derivative of x will be 1, so there will be nothing to worry about. And that's why people do that. Now, I can write this in a different form, maybe to better prepare, so you can better see what's going to happen here. So I'm going to write this as a x, that's u, multiplied by e to the power of negative 2x dx. And that will be my dv. See, that will be something that I can integrate, because e to the power is something that I really like to integrate. So for now, I'm not going to worry about this limit 0 and 1. I'm going to just worry about the derivative. So if x is u, and if e power of minus 2x dx is dv. So we have to take derivatives of the first and the antiderivative of the second. So derivatives will be ones, so I just have dx is same as a du. And for the second, when I start to integrate these, point of story is to get integral, not letter s. That you get v out, that's ingredient in that formula. And then antiderivative of e to the power is exact same thing, but now I need to have not x, but minus 2x. So that minus 2 always goes down in denominator. It's always like that. You can do substitution and if you want to check, but the point is always going to be denominator. And now I'm going to set up this new favorite little structure, such as a u times v minus integral v times du. So we're going to get this u, which is x, v, which is this fraction. So x is multiplied by negative 1/2, or you could just put it the way it is, e power of minus 2x over negative 2. The first product. Now the second product will be with a minus sign. And now we're going to integrate. And what do we integrate here? Well, it's a v, which is, again, the same thing, e power of minus 2x divided by negative 2. Notice that negative 2 I wouldn't care about. I'll just take it out. And du, which is dx. So again, my integration becomes so much nicer, so I can definitely perform it. Did I lose minus 2? Yes, don't lose minus 2. So the first product is going to look like x on the top and 2e power of 2x on the bottom. Usually we don't like to have negative powers with e or with whatever, so we just bring it down. For the other one, I have a plus sign and a half comes out, right? So I take out that negative 2 in denominator, and then integrate my same exact expression that I just did up here. So it'll be again, easily say negative 2x power divided by another negative, and plus the constant. And then you can just combine these two together, so you can just rewrite everything. But point of story, we're done at this stage. And this is great use of integration of parts. Wanted to take a look at the problem in the next section, because we already did them. Just one. I know I promised, due to respect to the coming holiday, to let you go today earlier so you can, well, kind of enjoy it if the best I can do for you. But that's, I guess, nice to know. And I actually also have a big announcement to make about the final exam, because our schedule this semester for the fall is kind of odd, because our final should be right after the Thanksgiving holiday. It should be on Monday, right after the Thanksgiving. And I think this is not gonna be a very good idea for some people that are serious about celebrating Thanksgiving. I know it's family holiday and there's not much you can do, right? Sometimes. So, and I don't want you to get like lower grade on the final, because it's a way that our college scheduled it. So what I can do is help you with that. What I can do is make an optional final. How about that? Actually, a student recommended me to do that, and the other students got so excited about that. And since we actually covered the material, I will look at the problem in section 6.2 right now. I'll do one, let's say number 12. Looks like that's kind of, looks like messed up exercise. So I will also on Monday maybe take a look at section 6.3, but it's like optional sections, because we really covered the material. And I also told you that I could take a look at some of the word problems in the remaining time we have next week and the week after next, actually, before the Thanksgiving. So I have time, I can take a look at some of the applicational exercises. But I know that some of you just don't need it. And I know that with this holiday season, some people may not have advantage, because they'll have to also study for the other finals, right? You have another finals coming again right after the Thanksgiving. How about that? So what I can do is give you the same grade that I have on the Canvas, course grade, for people that happy with their grade. Let's say you got a B and you say, oh, that's just what I needed. So, okay, turn in me your homework for the final. So up to section 6.2. That just, you know, same problems that done in class. I don't think it'd be very hard, right? And I'll leave your grade the way it is, unless you want to improve it. So let's say I got a B, but Alex, I want to get an A. Okay, I'll give you the final. It'd be the same thing as a midterm. I pre-planned it already, but because of the schedule thing, I decided to give some people a break. Those that happy with their grade, I'll leave your grade the way it is. So check your Canvas. If you can't, for whatever reason, ask me. I will tell you what your grade on the Canvas is, and that'd be your grade for the course. And that way you can concentrate on studying for your other finals in this Thanksgiving week. And I hope that'd be helpful in some cases. The other people that interested in spending more time, of course, I'll be on Zoom next week, week after next. We can do some more stuff, but it'd be just optional. And if you want to improve your grade, of course, I will do the same thing I did with a midterm. I will send you practice for the final, then I will email you a final, so then you will take it, I will grade it. So this is something that I will do, but I want you to let me know if you're happy with that grade. Just email me and make sure you tell what class you're in, because some people just send me email and I can't really decide what class this is, so I can confuse sometimes with the other students. So just tell them in the math 148 and I'm happy with my grade on the Canvas, and just submit your homework sometime whenever you're ready with it, and that'd be good enough for keeping the same grade for the class. And if somebody wants to improve, I'm always open for that, so we can discuss. If you don't like your grade, I guess first thing is take the final, and then we can, after that, see what else we can do. So let me do problem number 12, and I will let you go and relax a little bit. And yes, exactly. So if you decide to take the final, if you don't like your grade, I already told you that you can improve. So you just check what you have on the Canvas. When you say, I already have A on the Canvas and I want to take the final anyways, that's fine with me. But I know that some people may not have much time for that, and that's the main idea why I decided to give you a break this semester with this. It's not going to be next semester. Next semester, we don't have Thanksgiving, so there'll be just a regular final exam. But this schedule is messed up, and there's nothing we can do. So whoever did it, they should have either scheduled finals earlier or most likely after, because we used to, I think, have finals not right after the Thanksgiving. We had a week, few more class meetings, and then we had week of finals. So at least I could do the review before the final. But now I'll have to do a review before the Thanksgiving, and that's what I think is going to be not the best idea. So yeah, if you need a break, just email me. Make sure you email me that, so I will already put in my notebook that same grade that you have on the Canvas, and that's it. So, but you decide. I'll be, of course, on Zoom on Monday, so we can discuss some more. So let me do problem number 12 and let you go. I'll let you go. So problem 12, I think it's interesting exercise. Yes, you're very welcome, because I know that nowadays some people need a break, so, and I totally respect that. So e to the power of y is multiplied by square root from x plus 1. So it turns out we need to separate our variable letters x and y's. And the way we separate, first of all, I'm going to multiply by that dx, both sides of this equation. So dx will go to the right side. And then I'm going to divide by e to the power of y, both sides. So e to the power of y goes to the left. And this way, I have separated my variables, and in differential equations class, it's called separable differential equation. That's probably the easiest one to work with. So we're gonna now integrate both sides. So we're gonna integrate square root x plus 1. And I think something very similar I just did, and I just erased. It was on the same place as before. So with this one, I'm gonna do the substitution. Instead of x plus 1, I use u. So instead of dx, when I take derivative, I get clean dx here. It'll be du. And for the other one, I will think of integrating e to the power of negative y dy. And we already know that if it's a variable y or x or t dy, root dy or root dx. So we take antiderivative, it'll be e to the power of minus y over -1. I don't write the constant, I will write it only once. And the other integral will be a square root from u times du. And I called this radicand, this x plus 1, as a new variable so that we can use the favorite power rule. So I'm going to integrate u to the power of 1/2 that we already did today, of course. So we can keep that same e to the power of letter -y the way it is. So I can just write it as 1 over e to the y, somehow like that. Actually not, I'll just keep it like that because there'll be one more step here. So I will just copy it the way it is, e to the power of -y. So negative from denominator, I can bring outside in front of that, like that. And then the power of u will be 3/2, right? U to the power of 3 over 2 divided by same 3 over 2. So integral is gone, so I put plus the constant. So it's not over yet because I have to return back to my original variable. So I don't need that little variable u. I have to put instead of it x plus 1. So it's still minus e to the power of -y. So put negative. And then we have on the other side this 3/2 reciprocated, so it's 2/3. And there'd be instead of u, my original variable x plus 1 raised to the power of 3 over 2. 3 over 2 plus the constant. And then I always need to get the answer as function y of variable letter x. So how can this be done? Well, first of all, I can pull out negative, so I can multiply both sides by -1. So this minus will disappear here and appear on the other side. I say it'd be minus constant then. Well, constant is a constant. It could be -5, could be +5, could be anything. So just don't touch constant. Never touch constant. But to pull out y, now I need to use logarithm. Remember that if I apply ln, then we're going to have the power rule of logarithm that brings this in front. In fact, ln e is 1, so it'll be just minus y. The reason is that ln e, if you remember, is 1. If you don't, put this in the calculator. So minus y, if I apply logarithm on both sides of this, will be a -y here. So I already found function y of x. Whatever it is on the other side, ln minus 2/3, I just copy. And of course, I need to change the sign once again. So that'd be a positive and a negative. So I found solution for this little equation. It's a negative. ln of this whole thing, whatever it is, I just copy it. And plus the constant. I say that should be ln constant. Well, ln constant is still a constant, so we'll just keep it like that. Constant means it's just some fixed number. Could be 5, could be ln 2, or whatever else. So it just doesn't have variable in it because it's constant, doesn't have variable x or y or anything else. So the idea of this solutions of differential equations of this kind is to get rid of this differential. Don't have derivative, in other words. And to get rid of derivative, you use antiderivative. So that's what it is. So anyways, as promised, I'm going to stop at this stage and I'll let you think about all that. The idea that we only have to take the final if you don't want to. And if you agree with that, email me. So I will mark my notebook. And if you're not sure and whatever, on Monday, we're going to continue talking about this. So one can say, Alex, so what homework I need to turn in then if I decide not to take the final? So you can send it to me at any time, either after the Thanksgiving or before, it doesn't matter. And you already know that you can do same exact problems that done in class. And I'm trying to get back to the contents of this textbook so we can see what was with it. For the homework for the final exam. We stopped, I think, at logarithm chapter. Is that like chapter 5? No, chapter 4. So that was chapters 4 and 5. Chapters 4 and 5. So for the homework, and that's for everyone, whoever takes final or doesn't. So chapter 4, let's see, what we didn't do is last section, right? Yeah. So 4.1 through 4.3. Again, it's not just 4.1 and 4.3, it's 4.1, 4.2, 4.3. Then we also looked at the chapter 5, and that was 5.1 through 5.4, right? 5.1 through 5.4. And from chapter 6, let's say just 6.1 is good enough. 6.2 is that equation, so I guess we can disregard that. So these will be homework that you should turn in. And as I said, next weeks, I will be just working a little bit more with these exercises. So by request, so I think 6.2 does not really have much in it. So I will look at 6.3 also, but 6.3 make an optional because that's already material of calculus 2, pretty much same thing. And then after that, I will return back and see how we use derivatives for applications. For those people that are interested in this, if you again don't have time, we're not going to do that. Or if you want to do something else, you can tell me what else you like to do. Because they're nice topics. I just didn't want to overload you with some tedious exercises that some people will just blank on, get into panic, because they're same exact things we did, the derivatives and the derivatives, but functions are real not good because they come in from real life situations. That's why they're no good, because in reality, we don't have such perfect function as x squared. We have something x to the power of negative 0.0 something. So that's why it's not very good looking. So that's why for tests, I don't think people appreciate when I do this for the test. So anyways, I promise to let you go today with no quizzes, and also think about this idea of having no final. So have a good long weekend. And if you don't want to, I guess, get into any more calculus, you just email me your homework and email me if you're happy with your current grade on Canvas. I know that some people can't see it for some reason. So you have to be persistent. You just have to keep on clicking and clicking, and you will have it opened eventually. Because somehow this Canvas thing is not perfectly working. So I guess that's enough for today, right? So I'll let you go and